Before we leave this section on solving equations, we need to address one particular skill that will come in very, very useful as you move forward in your study of mathematics. And that's the idea of something called a literal equation. Now, the literal equations that you are most familiar with at this time are formulas. And what the word literal actually means is it comes from the Latin word for letter. And when we talk about literal equations, what we mean is solving them for one of the letters in the equation. So up until this point, we really only looked at equations that had one letter in them, that like one variable is usually an X in math class. Sometimes it's an N or a T, depending on a word problem that you might be looking at. But in science and in engineering and your applications of math, you will often have letters that represent whatever it is you're studying. And so, for example, you might have something like the area of a triangle is 1/2 b times h, where you're using the letter B for the base of the triangle and the letter H for the height of the triangle. And this is an example of what's called a literal equation, meaning it has multiple letters in it. And when you are faced with a literal equation, usually the directions will say something like this. It'll say solve for, and then there will be something after that, like solve for X, solve for Y, solve for B, solve for H, solve for something. And what that means is get the something by itself on one side of the equal sign. And you can put whatever you want in this blank. So it might be solve for y, which means get y by itself. And in fact, most of the time in algebra, that is actually what you'll see in your algebra class. But in a science class, you could be asked to solve for any number of things. And if you get into programming, a lot of times if you want to program a calculator or a computer to do something, you've got to do that algebra work on the front end to solve for whatever calculation you're going to want the calculator or the computer to do, and then you program that version of a formula into the calculator. So we're going to look at several examples of solving for these like literal equations, getting a variable by itself. And there's no new algebra in here. There's no new thought process to what we're doing and how we're doing it. It just looks different because you don't have as many numbers in the equation. You have more variables. So we'll look at this example to start with. You could see something like this, and it might say solve for X. Okay, and the way you want to interpret that is get X by itself. So if Y were a number, okay, so I'm going to just do a little bit of scratch work. All right, so let's just say Y is a number there. Well, what would you do first if you were solving for X? You would subtract 2 from both sides, and you'd get this. Now, because they were both numbers, you would do 4 minus 2, and you would write a 2 here. But I want you to note that the algebra process is still the same. So if my goal is to solve for the X, or get the X by itself, and if my first step down here was to subtract 2, then my first step here will be to subtract Y. Let me get this out of the way. Now here's where it starts to look different. Right here, y minus y is 0, so that doesn't change. Math is beautifully consistent in that how this like plays out, the reasoning behind it, why we do what we do, and why things cancel out. None of those things change, which is why it's so important that you understand the concepts of why the algebra works, not just that you're able to carry out steps. Now here's where it's different. If this were a 2, you could do 4 minus 2, but it's not a 2, it's a y, it's an unknown. We don't actually know what we're subtracting from the 4 there, and so we have no choice other than to just simply write it as 4 minus y. It can't be simplified any further than that because we don't know the value for y. Now remember, in our other equation, if you had 3x equals 2, you would divide both sides by 3 to get the value of x. Well, our algebra is still the same. You would divide both sides by 3, 3 over 3 is still 1. Now over here, notice that I drew a longer fraction bar there. That's because I'm dividing everything on the left-hand side by 3. I need to make sure I divide everything on the right-hand side by 3. Here, okay, on this side, we would do the subtraction. We do like the 4 minus 2, and then we divide the result of that by 3. So in order to preserve the order that we would be doing things, we want to make sure that we're grouping the 4 minus y together in that numerator. So we would do 4 minus y and then divide that by 3. And here's where students sometimes they're like, wait, that's it? Yeah, that's it. That's your answer, 4 minus y. Divided by 3. You might see it done this way. You might see, instead of the single division, you might see it separated. And that's kind of like undoing the adding of your fraction, or in this case, the subtraction of the fractions. Like if you had 4 over 3 minus y over 3, you could combine that because you have a like denominator, 4 minus y over 3. And this is just going in the other direction. Whether you do that or not is either personal preference, or it kind of depends on where you're going to go on the problem with the problem from that point on. Now, you could also have this same problem and be asked to solve for y, which means that you would be trying to get the y by itself. Well, I have a positive 3x right there. If I wanted to move that, I would subtract 3x from both sides. 3x minus 3x is 0, leaving me with the y. And then, just like in the last case, you don't have a value for that x, so you can't go 4 minus 3 is 1. The 4 is just a 4. The 3 is being multiplied by some number, and we don't know what that number is. And so we can't just assume that that would be equal to 1x. We don't know what x is. And so the furthest you can take it is 4 minus 3x. So what we did in this example is we started with the same equation. One of them we solved for x, the other we solved for y. And hopefully that clarifies what we mean when we say to solve for. So pretty much the rest of the lesson, I'm going to work through several other examples of things that you might see. We're going to look at the formula for the perimeter of a rectangle. So the formula for the perimeter of the rectangle is 2 times the width plus 2 times the length. So if you've got your rectangle, you have your width, you have your length. If you were to do W plus L plus W plus L, because remember perimeter is the distance around the outside, basically you're adding up 2 L's and you're adding up 2 W's. My experience is that it's more important for you to remember the definition of perimeter, because you can come up with that formula really easily than trying to memorize just a formula. Now that formula in its current state is solved for P. We're going to go ahead and solve it for W. Okay, so that means we want to get the W by itself. I'll go highlight the W in red there. So in order to get the W by itself, the W is being multiplied by 2, and we're adding a 2L. We're going to reverse that order of operations, so we're going to deal with the adding first by subtracting 2L from both sides. We have all kinds of unknowns. I don't know P, I don't know L, so there's nothing I can do with that other than to simply write P minus 2L. That's all we can do, because we don't know the value of P or the value of L. On the right, 2L minus 2L is 0. Now I have 2 times W. And again, if you're dividing everything, you want to make sure you divide everything on both sides, because if you had the numbers here, you would do that multiplication, then the subtraction, and then the division by 2. And I'm just going to switch the order here. So I have like P minus 2L all over 2 equals W. When I rewrite it, I'm going to rewrite it with the W on the left-hand side, just because it's a little bit more comfortable that way. Now, what this allows you to do is, the problem that I'm looking at is, find the width when the perimeter is, something and the length. Where I personally would find this more useful is if I wanted to program like my graphing calculator or something to find the width. So you have some kind of situation where you know the perimeter and you know one of the two dimensions of your rectangle, and you have to find the other dimension, but you need to do it over and over again, so you want a computer to do it for you because that's what computers are good at, is you could take this version of the formula and actually program it in to your calculator. Let's take a look at, not that one, that was a weird one. Let's take a look at this next one. This is an interest formula. So from like finance. Okay. And typically like A is like the amount of money in a bank account. P stands for the word principal, which is the amount that you invest. R is an interest rate, usually expressed as a decimal, and T is the amount of time that you would put the money in that account. And so the directions for this particular problem say to solve for P. Now, this is going to get into a concept that we haven't seen like at all yet in algebra, but we will see it. So if I want to get the P by itself, what complicates this problem is that you actually have the P in two different terms here. And so you might say, oh, well, I want to get the P by itself, so I'll subtract this from both sides. Now, if you're taking notes on this, don't write this down. But let's say you did that. You're like, all right, we're going to subtract that. And so you're like, great, I got the P by itself, except you didn't, because the P is over here and as well, and it's definitely not by itself over here. And so we've kind of gone around in a circle. So what we need to do for the first step here is we're actually going to use the distributive property. So to review that, remember the distributive property is if you have something like this, where you have like a 2, we'll start with some numbers here, okay? So a 2 and it's multiplying the parentheses. Well, we could multiply through and we would have 2 times x plus 2 times 4. And then we would normally just write that as the 8, okay? I'm gonna back that up a little bit. That's what we have here, except we're gonna go backwards. So we have P plus P times RT. And we're going to carry out the distribution, but we're going to go backwards. We're going to say what was distributed there. Like how could I rewrite that so that it would look like the distribution before the distribution? Well, you can tell that the P is taking the place of the 2. The problem is that I don't have anything here to figure out what should go in the parentheses, but bear with me here. Hopefully you can agree that P is the same as P times 1. I'll pause for a moment so that you can just kind of think that through. So what we're going to do here is we're going to take the P out. We're going to undistribute the P. So that means the P would be on the outside and we'd be left with a 1 plus, and then over here we're left with the RT. So just to kind of reiterate that, if you were to distribute this, you'd have P times 1, which would be just P, and then P times R times T, which is PRT. So my first step in doing this is actually going to be to undistribute that P. It's distribution, but in the other direction. Now, the name for that is factoring out a common factor. So we haven't talked about factoring yet. We haven't gone through that process. A large part of Algebra 1 actually is learning how to do the factoring. But for now, just kind of let that seed be planted, like let it soak in that what we did was we undid some distribution there. So we know that distribution is just fancy multiplication. It's multiplication over the parentheses. And we know that multiplication is undone with division. We also know that math is really consistent and the rules that work for simpler situations also work for more complicated situations because math is great like that. So what we're going to do is divide. I actually don't have enough space there. Hang on a second. Okay, I just like move that over a little bit. So we are going to divide by whatever we're multiplying by, which in this case is 1 plus RT. Now, sometimes people will put parentheses around there. Those are cosmetic. They change what it looks like. It just emphasizes the groupingness of it. So those parentheses I just put in on the bottom there, they don't serve any algebraic purpose. They just highlight kind of the group that we have something divided by itself. It just creates a little visual change to it, but they are not required. Okay, so sometimes you'll see them, sometimes you won't. And then we have to divide the other side by the same thing. So notice that none of the algebra rules here are new. It's division undoes multiplication. So we're going to divide. We divide by whatever is going to cancel to give us that 1. And then we adhere to the golden rule of algebra, which says you do the same thing to both sides. So none of the algebra concepts are new. They just look different. Now, just to reiterate why these cancel, we know that like 5 over 5 equals 1. And we know that negative 1.2 over negative 1.2 is 1. And we know that x over x, provided x does not equal 0, is 1. Therefore, 1 plus RT over 1 plus RT would be equal to 1, because math is awesomely consistent. You're going to be so tired of hearing me say that, but it is. So once you get that concept down, you can actually do a lot more things than maybe you've been taught how to do because you've been taught the concepts. So that then cancels out, and I want to be really careful about how I cancel that out. I'm just going to draw one big line through it. Don't do this. Okay, that is not how they cancel out, and that's actually a pretty significant math error to think of it that way. So if you are taking notes and you wrote that down, really go back, erase it, rewrite it. Don't let that mistake sit in your notes. I'm aware that at this point in Algebra 1, you probably don't realize why that's a very serious mistake, but it is a very serious mistake. You just have to trust me on that one. So if you're going to draw the line through it to show that they cancel out, make sure it is one line and you're showing that you're canceling out those groups. So this leaves us with a P, and I'm going to do what I did in the other example. I'm going to switch the order of that. And there you've done it. You've solved for the variable. So that pretty much is everything you need to know. A lot of these problems will go on and they'll give you some kind of value for A or R, T. And at that point, you just plug the numbers in and then evaluate the expression. So, but I think the concept of the literal equation with the formula that we've done, I think 4 examples of it in this lesson. So next thing you really need to do is practice it on your own. And I'll try to pick a decent variety of things for you to look at for your practice problems. All right, so the first 5 of these are pretty much on par with what we covered in the lesson. So solve for H, area is equal to 1/2 the base times the height. Solve for the length, that's the volume of a rectangular prism. V equals L, length times width times height. Solve for C, so S is equal to C plus RC. And solve for H, V is equal to pi R squared H. This one is a formula for markup, for when you're marking something up like in a store. Okay, this is the volume of a cylinder. And then this one, solve for y, 3x plus 4y equals 12. I put a little asterisk because that's the kind that you'll see most often in algebra class. So you'll have an equation with x's and y's, and you'll have to solve it for y. The last problem is a word problem. A rectangle is 1.5 times as long as it is wide. The perimeter is 75 inches. Find the width. So for that one, draw a rectangle, label the length and the width, and then use the information given and the formula for perimeter to see if you can figure out what the width is. Pause the video at this point, work out these problems, and then unpause it for a review. All right, let's take a look at these. So for the first one can be a little bit tricky because of the 1/2 in there. So you have a couple options for how you can deal with that. And you might want to go back and look at one of the previous lessons on division of real numbers and solving equations that have like the fractions in front to kind of review where this comes from. You can divide by 1/2, but if you remember, the definition of division is multiplied by the reciprocal. And so when we have divide by 1/2, that's the same as multiplying by the reciprocal of 1/2, which is 2. And so rather than dividing by a fraction, it's easier to multiply by 2. So I highlighted that in purple. So we end up with 2a. 2 times 1/2 is 1. Okay, just to like reiterate that. So that's 2 over 1 times 1 over 2, which is 2 over 2, which is 1. And then divide both sides by b. B divided by b is 1, and that gets your h all by itself. So you should have 2a all over b on that one. For the second one, if we want to get L by itself, then we need to divide by W and H. Some of my students will ask me sometimes, well, can you divide by them both at the same time, or do you have to do it separately? I would do them both at the same time. Otherwise, you end up with some really nasty looking fractions there. So if you tried to do it one at a time, make sure you study what this looks like and make sure you know that you can do them both at the same time. Now, something you do want to be careful of. If you have written this, okay, where like the where the H is like peeking out from underneath the fraction, please go correct that notation and make sure that both the W and the H are securely in the denominator of your fraction. Because if they're not, like, it makes a difference. It makes a difference for how they're grouped and what the order is that you would do your operations in. So with the one that I have written there, you would multiply the W and the H together first, and then you would do V divided by whatever that product is. But if you have this, then you would do division, V divided by W first, and then you would multiply that quotient by H, and it will give you a totally different answer. So please be careful about that like your fraction bars, it's really clear where they're intended to go. For the next one is very similar to the one I did with the interest. So just as a reminder, I put in like the times 1 there to remind you that when you undistribute that C, you're going to be left with a 1 because C times 1 would give you that C there. And then this time we're dividing by 1 plus R. If you did do a line to show that cancellation, make sure it is one line. That signifies that you're canceling out the 1 plus the R as a group together, and you're not trying to cancel them out separately because they actually don't cancel separately. They cancel out as a group. So you should have S over 1 plus R. And again, watch the length of that fraction bar, because 1 over, like S over 1 plus R is not the same as S over 1 plus R. Okay, those are two different things, and it's important that you say what you mean when you're writing your math. So please be careful about that. For number 4, we have to solve for H. And so as with the previous one on the last slide, you want to divide by the pi r squared, because pi over pi and r squared over r squared, that whole product is equal to 1. And you might be like, but you just told us that they don't cancel separately. Yes, the difference is the addition. So if you've got the adding and subtracting, it has to cancel out as a group. If you have factors and it's multiplication, they do cancel out like individually. But you don't have to. You can cancel them out as a group as well. So you should have V over pi r squared. And again, make sure that all of the pieces of that are securely in the denominator and numerator. This one, so we want to get the y by itself, so we'll subtract 3x from both sides, but remember x is a variable, so you can't actually do 12 minus 3x. It's not 9x. If you wrote 9x, give yourself a little x on it, like got that wrong, and correct it, because you don't know what the x is. So you have like 12 all by itself, so minusing or subtracted by the 3x and you don't know the value of x. So you can't assume that that's going to be equal to 9x. And in fact, it won't be unless x happens to be 0 or 1. I think that would both work. No, even if it's 0, it doesn't work. I should not go off. 0 doesn't work. I think it only works if x is a 1, then it works. And we don't know that x is equal to 1. So don't go there. Then divide everything by 4. And you'll notice that I rewrote that in a different form where you could split it up. So 12 divided by 4 would give you the 3, and then you'd have the negative 3/4 times x. And you're probably wondering, why would you do that? Sit tight on that. If you wrote this answer on the left, you're totally fine. Don't sweat it. But just kind of file this one away as something that you could do. For the last one, I said, before you quit and give up and say it's hard, it's got words in it, you don't give up on it, like try some stuff. So, but not this. Don't try this. There we go. Let's label that correctly. There we go. So we have the perimeter here. We're told that the length is 1.5 times as long as it is wide. And so I wrote length is 1.5 times W. That's a direct translation into the algebra. The formula for perimeter, and you could look back in our lesson for that, is 2 times the width plus 2 times the length. So what I did was I said, well, I know that the length is equal to 1.5 times the width. So I did what's called a substitution. And I took out the length and I put in 1.5 W. Now, this is actually something that we'll study later in the course. So if you didn't think to do that, that's totally fine, as long as you tried. 2 times 1.5 is 3, and that's all multiplication going around here. So it's 2 times 1.5 times W. So you can go ahead and do the 2 times 1.5 to get 3. 2W plus 3W is 5W. Then I kind of run into a roadblock. So we're told that the perimeter is 75. So I substituted in a 75 for the P, then divided both sides by 5, and I got the width was equal to 15 inches. It's possible that you could have gotten that by doing guess and check and any other number of strategies that are algebraically sound to try, which guess and check is algebraically sound. All right. So this is the last lesson in our 3rd unit, and we will look at graphing next.